series of webinars. It's hosted by Mr. Karsten Strootman from the Men&Mice Professional Services team. I am your facilitator, Paul Terrell. I'm with the Men&Mice sales team. Really, my role here is purely for housekeeping. So during the course of this webinar, I'd be happy to take any questions. All you have to do is use the messaging feature here in GoToWebinar. And any questions you ask, I will collect. And then at the end, we will have a question and answer sessions. So again, any questions either related to the webinar or if you need any assistance, I'm here for that. Also, it's important to note that at the end of this webinar, it is being recorded. It will be posted out to our website, and all the people that signed up for it will be receiving a link to that. So without any further ado, I will hand control over to Karsten. Thank you, sir.
Thank you, Paul. Hello. Welcome, everybody, to our IETF 93 review. So IETF meeting was last week in Prague. And I wasn't there, but I attended remotely. Before we jump into what's happened at IETF 93, I would like to inform you about a security issue with Bind. Now, this came out late on Tuesday, and there is an issue with a Bind name server handling the T-key record queries. So, and this is regardless whether you have T-key records in your zones or not, or whether it is an authoritative server, a caching server, doesn't matter if it is Bind 9. And if it is any version of Bind 9, no matter what zones, no matter what configuration, it's vulnerable to this security issue. So if you are running Bind 9, you should upgrade to the latest versions. The latest versions are 9.10.2, patch number 3, and 9.97, patch number 2. Versions. Men&Mice has packages for various operating systems, Solaris, Red Hat, Debian, on the packages.menandmice.com website. Also, your Unix, Linux vendor should have the patch packages out by now, and you can also grab the latest source code from the isc.org website. So, about IETF in Prague, as always with our IETF reviews, I've collected some interesting stuff from DNS, DNSSEC, DANE, DHCP and IPv6. Of course, that's not everything that happened at IETF 93. There's a lot more, and here's the link for all the materials. If you want to dive in, you find all the presentations, recordings of the sessions, and much more on the data tracker IETF.org websites. Without further ado, DNS. So this is the list of all the RCs, DNS-related RCs that have been published since the last IETF. Last IETF was in March this year. And there we have the standardization of the so-called null-MX record. And I will cover that on an extra slide in a moment. Then we have two RFCs about the AS112 name server operations. AS112 are the special name servers in the internet that take all the reverse lookup queries for local IP addresses, the RFC 1918 IP addresses that are usually only or should only be used in local networks, but sometimes reverse lookups for these domains and for these IP addresses escape the local networks and go to the internet. And for them to have some place to be trashed, the IANR and other people run these AS112 services. And these new RFCs, they just describe how the services are run. Then we have a new DNS resource record, which is the URI resource record. I will also cover that on an extra slide in a moment. And the last one is RC 7558, requirements for scalable DNS-based service discovery and multicast DNS extensions. Now, multicast DNS and service discovery, these are stuff that most people know from iTunes or related Apple technologies, which is the way how iTunes can find shared music libraries from other people on the network. And it is only specified for local networks, so it doesn't cross routers. and there are requests from large networks, universities, but also enterprises to have this multicast and multicast DNS and DNS service discovery working cross router boundaries. Reason here is that today quite a number of other services like printers can be discovered through these technologies. And if you have, like in the same room, you have wireless and you have wired networking, it's only possible to discover the printer on one of those because they are not converging. There's a route in between, so it's not possible to have the printer discoverable on the Wi-Fi and on the cable-based network. So the IETF is working on solutions, and this document specifies and documents the requirements. So the null MX record, this is something that people have used in years to specify that a certain domain name or host name does not receive any mail. Reason here is that the SMTP, this simple mail transport protocol, defines that a sending mail server will first look up an MX record for the recipient's domain, and if there's no MX record, then it will automatically fall back to the address records, either an IPv4 or IPv6 address record. Now, if the sender of an email makes a typo mistake, or some people just copy and paste from a web page, and there's something like name at company.com in the name, that wouldn't work, and the email will get sent to the sending mail server, and it will stay there for a week. And the mail server will always try to make connection to the address records of that name. And only after a week, the original sender will get a bounce email and will detect that that email never received the recipient. Now, in order to solve this problem, it's not possible, but it was always possible, but now it's documented, it's an internet standard to do so, to have an MX record for a name that doesn't receive email with a priority of 0 and with the name of the mail server just having the dot. Now, the dot is not a valid host name for a mail server, so that indicates that this domain name on the left-hand side doesn't receive any emails. The second new resource record that has been discussed in a recent RFC is the URI DNS resource record. Now, that has been in development for a long time, and the URI resource record is already in most DNS software. So if you run like bind software, it's already in there and you can use that. The URI resource record is very similar to the service SRV resource record, with the difference that it returns a full URI instead of just a host name and a port. So you can even have for an HTTP server, you can even have a path to the website, not only the host and port number. So the domain name, the owner name on the left-hand side, it's encoded the same way as the SRV record. It has the underscore and then the service name, dot underscore, and then the transport, TCP in this case, and then the domain name, time to live, class internet, record type is URI. Then we have a priority, meaning that a service client should always first try the entries with the lower priority and then fall back to a higher priority. And then we have a weight, that is load distribution among all the entries with the same priority. And then we have the URI in the back. Now, I just see that the example I made here is quite of nonsense, because the URIs should be different on the right-hand side here. Should point to different servers or even different pages. With that, it would be possible to have load balancers for the first two, point that to two different web servers, and have the third one a fallback. Maybe a website is currently in maintenance mode website. So if the first two are not reachable. So new developments. There is ongoing work on DNS transport over TCP. We will also talk about that when we come to the DPRIVE, the DNS Privacy Working Group. There's much request nowadays to run DNS traffic over TCP because TCP has some benefits over UDP. It, for example, prevents amplification attacks because the source address is not spoofable. At least it's much harder to do that with TCP than it is with UDP. It allows for privacy, for encryption with TLS, transport layer security, and also it prevents some fragmentation issues with larger answer packages that we see in IPv6 networks nowadays and with DNSSEC. The document, the updated document, specifies that clients should pipeline the queries over TCP, meaning that a client, when sending a query, should not wait for that answer first to return before sending the next query. It should just send all the queries and then receive the answers when they come back over the TCP session. And these answers can even be out of order. So it's not required that the answers coming in the same order that the queries are being sent. And with technologies like Keep Alive and persistent connections and pipelining, DNS over TCP can actually be as fast as traditional DNS over UDP. There is a small latency when making the connection first time, but once the TCP session is on with the server, DNS traffic can flow quite fast between the client and the server. In the same category comes the eDNS TCP Keep Alive option, which is an extra option where DNS clients resolvers and authoritative servers can negotiate how long they would like to keep the TCP sessions open. And that allows then the clients to do the pipelining to send multiple queries over the established TCP session. It works in the way that the client initiates the request and opens the TCP connection and sends an empty eDNS 0 TCP Keep Alive option. And then the server responds with the amount of time that the server is willing to keep the session open. Now the server can dynamically adjust that based on the resources available on the server side, the load available on the load on the server side. And then the client has some indication how long the session will be open. With every answer coming back, the server can adjust the timer. So if the server detects that his resources are running out, he can just shorten the Keep Alive or even set it to 0, which means to the client, please close this session immediately after you receive these answers. Completely different, but also important, is the key signing key rollover in the root zone. The Internet DNS root zone has been signed 5 years ago. That was in July 2010. And as every key signing key, also the root key signing key should be rolled from time to time. One specific reason for doing it now is that the hardware security modules, the HSMs, that keep the private parts of the key signing key secure are getting old and are running out of support and need to be replaced. Because these HSMs work in a way that the key signing key should never leave the HSM, and it is technically not possible to extract the key signing key out of that. If new HSMs are being bought and put into place, the key signing key needs to be rolled and a new key signing key will come into effect. Now, the IANR and ICANN, which are doing the oversight of the root zone, they are, of course, knowing that this is a very delicate task to do, because a mistake or a problem in rolling the root zone's key signing key can switch off larger parts of the internet. Currently, the amount of DNSSEC validation in the world is approaching 20%. So meaning that if the key signing key rollover in the root zone goes wrong, 20% of the internet are cut out of the from DNS name resolution of the internet, and that would be not a good thing. there are several issues that have been identified. One is that the publication format of the trust anchor is not standardized, because when the key signing key is rolled, all the validating DNSSEC resolvers around the world, and there are thousands or even millions, need to fetch a new trust anchor for the new key signing key. But how that new key signing key trust anchor is published and can be imported, that format is not standardized. There is like a de facto standard, but currently there's no document describing it. Also, there's no documented way to do a secure bootstrapping of a DNSSEC DNS resolver. So if someone just installs after the key signing key trust anchor key signing key rollover a new DNSSEC resolver, that very likely comes with the old trust anchor. How now to fetch the new one in a secure way, and also devices that do DNSSEC validation, like CPE routers that are sitting on some shelf in some shop, might miss the key signing key row and might be pre-configured with the old key signing keys trust anchor and have no way to re-bootstrap. Well, this needs to be solved before the root key signing key is rolled, and IANR and ICANN is working on that. Very much similar in doing key signing key rollovers and doing testing, and that is a new project that had been announced in May at the RIPE meeting, and there was a presentation this time at the IETF. That's the so-called Yeti DNS project, and the Yeti DNS project is a worldwide experimental IPv6 only DNS root server system. So some people there are building a new root server system on IPv6 only, and it works as a large-scale testbed. The participants here are DNS experts with various background and interests, and also experimenters from universities and other organizations. And in that project, experiments are being done. For example, experiments on how an IPv6 only DNS works. Does it work? Are there any problems in running DNS IPv6 only? How about the bigger packet sizes, preventing IPv6 IP fragmentation? Also, key signing key rollovers. The Yeti DNS project, because it's a research project, can do a root zone key signing key rollover anytime, and they did that in June this year, and they found already certain problems with DNS software like Unbound and Bind on the way. And they can do such a key signing key rollover much more frequently than it's been done in the real root zone. Also, they can roll the algorithm, play around with the signature sizes, and also do other changes with DNSSEC, maybe implement some experimental stuff that nobody would really do in the real root. So this project is not an aim to replace the IANR's root name servers. It's an experimental stuff. The project is looking for volunteers that would like or would help running resolvers against the Yeti DNS root, because it only works if people are using this root server system. If you want to participate and help in that project, and if you're running a DNS resolver, then you can go to the website. The URL is here on the slide, and you can find the information there, how you can reconfigure your bind, your Microsoft DNS, or your Unbound to use the Yeti DNS root name server system instead of the official IANR's root name server system. You need IPv6 because it's IPv6 only, and you should only do that on a network with informed users in non-critical environments, because it's an experimental system, and it can break and it will break. In the DNS operations working group, there was a very heated debate on the RC 6761 special use domain names. RC 6761 was created for domain names that are not delegated in the internet but still used widely in IP networks. One example is the .local domain, which is used for multicast DNS and service discovery. A second one, which will be in that registry shortly is the .onion domain, which is used for the Tor network. And now people from different other projects are requesting that their special use top-level domain is also being put in the registry. For example, .bit for Namecoin, exit for an exit node in the Tor project, .gnu and .zkey for the GNU-net overlay network, I2P for the I2P overlay network, and Tor for consensus among Tor roots. So there is demand for extra top-level domains. Now the IETF has now a problem because they are now trapped between policy and technical debate. There is technical reasons to set aside these names, but there's also the icon with the official root zone and the ability to designate real top-level domains in the internet routes, and the decisions with the from IETF could collide with ICANN's plans of publishing new top-level domains. So there was a long discussion here, and a new design team has been put in place to discuss what should happen in the future with this special names registry, because the namespace, that is the domain names people use, is not exactly 100% what DNS is using, because there are names that are outside the DNS. There are several proposals. For example, having an extra top-level domain delegated, and then everything below that top-level domain would be without regulation. There's the proposal for .alt, and new proposals say .ext or .external. And there was no conclusion on that discussion, how this should done in the IETF last week, and discussion will continue in the mailing list, and the design team will work on this issue. So that was the pure DNS stuff. Now we come to DANE, which is also DNS related, securing services using DNS and DNSSEC. There was one proposal which I found particularly interesting, was to have DANE records and the DNSSEC authentication chain inside TLS. Now, TLS is a transport layer security. That is what we use to make secure connections to website, among other stuff. TLS also works for other protocols like mail and Jabber. But most people know that as HTTPS, and using the older name Secure Socket Layer, or SSL. Now, there is a DANE standard for checking or validating TLS certificates by using the TLS resource record. That works quite fine nowadays between mail servers, but it has its problems for web server and web clients like browsers, because that technology is not built into the browsers today, and you have to explicitly install an add-on for that. Now, the browser vendors, they are reluctant to build that into their browsers because they fear that there are problems with this validation, because the client might be behind a DNS resolver that cannot do DNSSEC, or there's some firewall blocking DNSSEC lookups. This solution now will transport all the data, all the resource records that are required to validate the certificate over the TLS stream. That means if you request a secure website, let's say www.securewebsite.org, you're not only getting the website back, you're getting the certificate back, the public part of that, and you get all the DNS data in the HTTPS stream that you require to validate the certificate. The benefits here is that there is no additional DNS record lookups required, so it reduces the latency. It avoids all the problems with the client, the web browser, being unable to look up the DANE records because the DNS resolver might not know about them. And it allows the client to validate all the records without having a validating DNS resolver in the first place. And this new draft is co-written by some person from Mozilla. So it might be that this draft will pave the way for having DANE style validation of certificates in the browsers in the future, which I find quite exciting. So if the TLS client requests the site, the website, the certification chain is returned, the server, the web server performs all the DNS queries. So the DNS server will collect all the TLSA records, the signatures on the TLSA record, the DNS key records to validate signatures, and the DS records to validate the keys, and send everything to the client, and the client does the validation. The server will then cache the data according to the TTLs and can reuse the data if some other client requests the same stuff. The client then does the authentication using a pre-configured trust anchor. Another new DANE draft is the way to do client certificates in TLSA records. Today, with TLSA, we can validate certificates on the server side, so the client can authenticate the server, but not the other way around. There's currently no way with DANE for a server to authenticate the client. And this draft is about making that possible. It works in the way that the label for the TLSA record is for the host name of the client, and then prepended to that is a service name with an underscore for the service the user is using. Here it's SMTP client, meaning a client sending SMTP to SMTP port 25. Then there is much debate about SMIME and OpenPGP key. There was a lot of debate on the mailing lists here. There has been discussion how to store the email addresses of the owners of the key. When I presented you the OpenPGP key and SMIME draft previously, the idea was to use a hash, SHA-256 hash, shortened to 28 bytes. Now, there is a different proposal to use base32. The benefit of using base32 is that the DNS server can rebuild the email address from the base32 data and can make a dynamic request to a backend system and can fetch the PGP key or SMIME certificate directly from a database or from other backend system. So there's no need to have all the keys in the DNS zone. That requires, of course, dynamic DNS signing, DNSSEC signing, but some DNS server can do that, like PowerDNS can do that, which we will show in our next webinar. How that works. The downside of using base32 is a privacy issue, because with base32 all the email addresses, they are not in plain text but almost plain text, because it's very easy to just decode base32 and then you have all the email address being used for lookup of PGP keys and SMIME certificates. So some administrator snooping in some coffee shop on the query log of a resolver can find all the email addresses of people using the wireless LAN in the coffee shop and trying to send email. So this is a problem here, and there's ongoing discussion. However, the working group chairs, they set the date to 1st of August for getting a solution here, and after that the drafts will be updated. Both the SMIME and OpenPGP key drafts will be updated, and then probably going into working group last call before IETF 94. Another change that have been made is to use a different separator label. Instead of underscore SMIME cert and underscore OpenPGP key, is just now underscore add, like email address add domain name. So that was DANE. And DPrive, DNS Privacy Working Group. Again, TLS There's a draft to do DNS over DTLS. Now, DTLS is TLS over UDP. That has certain advantages compared to TLS over TCP. One is to avoid the head of line blocking. That is building up the TLS connection. So if we have TLS over TCP, we first have to do the initial handshake, both the TCP and the TLS handshake, and then we can send data. With DTLS, we don't have a session. We can just like with normal UDP, just send queries and get the answers in any order back. It allows fast session resumption, and it supports any cast, which is important for certain provider scenarios where the DNS resolvers are placed and addressed in any cast networks. But this also have problems. What about deep package inspection firewalls? If they see encrypted DNS on port 53, they might just block that and drop that. The possible solution here discussed is to use a different port for DNS and DTLS, and that is that has consensus in the working group. Another problem is how to authenticate the DNS server. Do I really speak with a correct server? Here, X509 certs could be used, either to have a self-signed fingerprint in resolve.conf or have the certificate name of a CA-based certificate in the resolve.conf or similar in systemd resolve and so on. One bigger problem that has been discussed is that this DNS over DTLS needs to be signaled, because not every network will have this not every resolver will have that. And if there is a discovery, if there is a signaling, then always a downgrade attack is possible. And some people in the working group argue that, okay, if there's a downgrade attack possible, then it's failed, and we should not use it at all. We should use a system that we know it's working almost all of the time, and that would be using DNS over a classic TLS, that is TCP TLS over port 443, which is also used for HTTPS. Oops, too fast, sorry. Going back here. So, no, we already had that. Deep drive. Then TCP TLS for DNS. In the draft, there was two options. One was to use a dedicated port. The other was to use in-protocol signaling of start TLS, as it's used for email. Consensus in the working group is now that always a new port should be used and no inbound signaling, because inbound signaling, we know that from email, has a problem that can be filtered out, so that allows a downgrade attack. A defined new port, which will be not port 53 for DNS over TLS, is the way to go. Also, the DNS over TLS will follow the best practices document, and because it's a new protocol to be developed, it can directly start with the latest TLS, which is TLS 1.3, and doesn't need to care about SSL version 3 and SSL version 2, which had all these problems, poodle attack and heartbleeds and all this stuff. There are already implementations. Unbound has TCP TLS support for a long time already. So even before the whole discussion in deep drive mailing group was started. It's now also in LDNS and drill. For troubleshooting purposes, there is a tool called Digit, which has support for DNS over TLS, and the new Get DNS API from NRNet Labs also has support for it. Sorry, I'm always using the wrong keys here. So here we are. And there was a third presentation in the deep drive working group about using IPSec for opportunistic DNS. And the question here is, why not encrypt all the traffic, instead just only the DNS traffic? And that could work without authentication. In the coffee shop scenario, if the DNS resolver in the coffee shop supports IPSec, a simple IPSec scheme without authentication, it would be possible to encrypt all the communication to the gateway, to the wireless gateway, and be secured against snooping from all the other people on the same wireless. Optionally, that could be limited to the DNS traffic only if that is wanted, and it has been presented as a proposed alternative to an in-DNS protocol solution. This proposal was only for the client to resolver, not from resolver to authoritative. The benefit here is that IPSec opportunistic is already available, and it is working with current implementations, so no new protocol work would be required. So that was the DNS part. DHCP, there was only one new RC, which is about the multiple stateful DHCP6 options. I've discussed the content of that draft in one of my previous reviews, so don't go deeply into that. And we talk about the new work of the DHCP working group. There's work on secure DHCPv6 and secure DHCPv4 using certificates and public-private key pairs. And that document has been updated. And there was a hackathon on the weekend before the IETF where the implementers of two implementations, one is IC with the Kia new DHCP server, and the other group was the White project with DHCPv6 that's coming from the BSD, free BSD part of IPv6 development. And they did a successful interoperability test between these two implementations. And also there's no support for IC DHCP for this secure DHCPv6 and DHCPv4 work in progress. It's not there, it's not stable, but even the older IC DHCP will get secure DHCP in the future. Good to know. And then there was talk about the DHCP anonymity profile, which is about randomizing MAC addresses and not disclosing the host name. The idea here is to prevent network owners to track people who are coming into the network, leaving the network. This is especially for public networks like hotels, coffee shops, airports, and so on. So there are different steps that can be done in the operating systems. One is to randomize the MAC address automatically, and also the client IDs, the DUID in case of DHCPv6, not sending the host name, and always changing the identity. And also limit the information disclosure when changing networks, because current implementations, if you shut down your machine and if you start it again on a new network, it will first probe whether it is on the same network again and will ask for the previous IP address, and that already can reveal certain information. And that should be stopped. It is done in the implementation in a way that first the operating system detects whether it is still on the same network, for example, by looking at the Wi-Fi SSID and also on the login credentials for the Wi-Fi. And if it's not on the same network, it will not try to renew its current lease. It will directly start requesting a new lease. There's a prototype implementation in Windows 10 done by the Microsoft team, and they choose not to send the host name at all. There's a different proposal to send a randomized host name, and Microsoft already did a small field trial in the Redmond, Seattle area, and they found only minor issues. They just had one public Wi-Fi network where that didn't work, but it worked in all other cases. And they are looking into why it wasn't working in this one network. Of course, more work needs to be done, but Microsoft is in the forefront here, and with Windows 10 being a rolling release, we might see that coming into Windows 10 in the future. Then there was a draft about relay-initiated releases. And the issue here is that sometimes clients leave a network without releasing a release. And in some networks, especially certain mobile networks and provider networks, the DHCP release is also used to keep state on more than just the IP address. For example, various services like data, voice, or video streaming, certain policy decisions, quality of service setup is bound to the lease. And if the lease is not released when the client leaves the network, then these resources are still held by the network. And that's bad. And the idea here of this draft is that the relay might be able to detect the clients leaving. So for example, if the relay is a switch and the switch sees the port going away and not coming back, then it might decide after some time that this client is just gone and will release the lease that has been assigned to the client. So the last two were just drafts discussed in the working group, but as so far not adopted as working group documents. Still discussion is going on. Last topic for today is IPv6 and IPv4 sunset. And because IPv6 is really taking up now, there's a lot of work to do, and there's a couple of new RFCs since last time. And I'm planning maybe to do later this year an extra webinar on what's changing in IPv6 over time. For example, the new duplicate address detection. Just want to highlight some work that has been done in the working group. If you look at the RFC documents for IPv6, like RFC 2460, which is the base IPv6 RFC document, you will see that it's still on draft standard, as are many other RFCs. The IETF in the past, they didn't really follow their own procedures. Usually the idea was that a draft standard would be advanced to a real standard, a proposed standard, after a certain amount of time when it's known that there's no bugs in the protocol and everything works as expected. But that, out of laziness, never has been done for IPv6 and others. And there's an RFC now, RFC 6410, requirements for internet standard, that makes it mandatory. So if a draft is not, if a draft standard is not forwarded to proposed standard, it will expire automatically after some time. So the working group now needs to work on making the old documents a proposed standard, and there was a big discussion whether just changing the label and leaving the content unchanged, or whether to rewrite and update the RFCs by publishing a new RFC. And that discussion is going on. The benefit of rewrite is that all the new works, as you see here in the updated byline in the picture, all that could be then merged into one document, which makes it easier for implementers to have everything IPv6 based protocol in one document. So same as with DHCP privacy profile, IPv6 working group is working on randomized MAC addresses and IPv6 assignments for Slack. Also here, enhanced privacy is the motivation. Users can then hide from the network and prevents location tracking. That has been implemented, but it conflicts with, of course, RC 7217, which is about having stable interface identifiers in IPv6. Also conflicts with SAVI, which is source address validation improvement for DHCP, and the working group is now trying to find a middle way between these different requirements. On the one hand, having the requirement for stable addresses in enterprise networks, and also having the randomized addresses and randomized MAC addresses in public networks. So it probably boils down in how to detect when I'm in an enterprise network or whether I'm in a public space network. Then there was a presentation from Stuart Cheshire from Apple about all the IPv6 news coming from Apple. The big part is that at the Worldwide Developers Conference in June, Apple announced that all iOS apps, that is all the applications running on iPhones and iPads, must support native IPv6, IPv6 only, that is, starting with iOS 9 in order to be allowed to come into the iTunes store. So all the developers need to test on IPv6 native only. And Apple will, on all applications coming to the store, will test that as well. Some people in the IETF reported already that that had an impact on their product development, that now their developers are now also implementing IPv6. That also requires for some applications that have backend services that these backend services also might be switched to IPv6. We will probably see a big push of IPv6 when iOS 9 will be rolled out later this year. The Happy Eyeball feature in iOS 9 and also in macOS 10 will now prefer IPv6 by some 20 microseconds, I think, headroom, and that, according to measurements by Apple, will mean that if IPv6 is available, IPv6 is used 99% of the time. And then they have implemented NAT64 internet sharing. I have an extra slide on that. That uses the 2001:/64 Teredo prefix. And there was some critics on the IETF on that and some discussion going on to use a different prefix. This is the prefix currently used in the beta versions of macOS 10.11, and we might see that changed in the final code. So NAT64, DNSSEC IPv6 only network. There is an internet sharing function in macOS 10, and the new macOS 10 has a little bit hidden function to create an IPv6 only internet sharing experience. You have to option click on internet sharing, and then you see an extra option that you can check on the bottom, which enables then the IPv6 only internet sharing. That is aimed for the developers of applications so that they can create pure IPv6 networks that is working and can go to the internet even if the internet connectivity of that developer is IPv4 only. That creates basically an IPv6 to IPv4 translation mechanism in macOS 10, and it's a nice way for developers to create an ad hoc IPv6 only network on Wi-Fi with their MacBook or other Macintosh machine. But be aware, NAT64, DNSSEC as used here will break local DNSSEC validation. So if you have then on the IPv6 only network, if you have an application that does DNSSEC validation, it will break. So it's not a solution for production networks. The design choices for IPv6 networks document has been updated. It now includes enterprise environments and their use cases. It has an extra new chapter on IGP routing choice options, covers EIGRP and RIPNG, and also has a new section on address choices. So if you work on an address planning or you plan to implement IPv6 in your networks, that is a good document to read, and it's even better now. And there was a new draft on solicited router advertisement as unicast. The problem here is in wireless networks, Wi-Fi networks, every device that is joining the network is sending out a router solicitation message. Basically, the device is asking, where are any routers here in the network? And then the router, by default, because that's the standard, is sending a multicast router advertisements to all devices. Now, if the Wi-Fi network, like in a conference situation, has hundreds of Wi-Fi devices, all the devices will wake up and will see, oh, nothing new, and go to sleep again. But that drains the device battery, because in these large networks, you have devices joining the network, leaving the networks all the time. So the devices never go to sleep, and the battery is drained in a matter of hours. Recommendation here in this new draft is that the router manufacturers should allow unicast router solicitations for this Wi-Fi networks, meaning that if a client machine is asking for a router information, then the router will just send the data back to that one client and not as a multicast router advertisement that will wake up everyone. And then there's another new draft on host address availability recommendations. This is about how many IP addresses should one reserve for a host. Now, from IPv4, we are used to have just one IPv4 address for every host. In IPv6, we can have easily more addresses. And the draft says that operators of network operators should not make artificial limits on the number of IPv6 addresses that are given to a host, because there are many benefits on having multiple addresses, maybe even having one address per service later on. And the recommendation here is to provide no hard, or to don't impose a hard limit, and if a limit needs to be given, then a full /64 should be assigned to a single host. So every host should then get a full /64 network for its own purposes. That has other benefits. For example, it makes neighborhood discovery much easier and saves resources on the routers, because the neighborhood protocol tables will be much smaller. And the last one, before coming to an end, is an RFC that I didn't have on my RFC since last time slide, but it has been published in April, actually 1st of April, and it's about scanning routing for IPv6, and it is about taking the greenness of a network path into the routing decisions. So IPv6 packages, they live in dark fiber and copper fiber, and they never see the lights. That is bad. So the idea here is to have an extra option flag in the IPv6 header that tells, or it's actually a hop-by-hop extension header that tells the routers to use a scenic routing, use as much fresh airtime for the package as possible, and choose paths based on AVN, IP carriers, or Wi-Fi wireless technologies. If you want to test that out, in August in Germany, there is possibly the largest outdoor networking event, which is the Chaos Communication Camp happening. And here we have a picture of one of the last year's 2007 camp. Many thousand people with network in a wood, and then you can test out in a live implementation scenic routing for IPv6. So that was my review of the IETF 93. Our next webinar will be about PowerDNS, an open source DNS server, and we talk about how PowerDNS can be used to manage DNS zones via SQL, so making changes to a DNS zone by doing SQL updates. PowerDNS also has a bind backend, we show that. We show the remote backend, which is basically a web service backend, so you can do JSON requests over HTTP to get DNS zone data. We show DNSSEC signing with PowerDNS, and we also have now a Men&Mice suite controller for PowerDNS, so you can use PowerDNS from the Men&Mice suite if you like to. Here's a link to the sign up. The sign up is not open, but it will be possibly beginning of August, so if you want, you can sign up, but you will also get emails from us in the meantime. And our upcoming trainings, we have an IPv6 class. It's a special 4-day class, like a bootcamp class. Instead of the normal 5 days, we have crammed the introduction and advanced in a 4-day class. We have that in the San Francisco area in September 8th to 11th. We have our DNS class, the introduction 2-day class in Arlington, Virginia, end of September, and then the DNSSEC technical workshop, also in Arlington, Virginia, in September, beginning of October, and another DNS in Redwood City in November. And we have more trainings coming up in December and next year. You find that on our training website. URL is on here. And that finishes my review, and we look for any questions.
We actually have received a question, Carson, and it's regarding the URI. So the question is, the null MX record is a new twist on an existing record type, but the URI is actually brand new. Is it safe to begin using that record type today? This viewer gets frequent requests from uneducated users that want the type of service to include the path to the web page.
Yeah, it is safe in case that nothing breaks if you use the URI, and the URI resource record is available in latest bind versions. So you have to check whether if you have the latest bind versions, then you can use the URI. However, I haven't done survey of which applications currently already using this record type. So in order to really make use of that, you need to have an application like a web browser that makes use of the URI resource record. I haven't done that. It might be that it is supported already by certain browser types. I don't know. I can figure that out and yeah, maybe send an email or post that as a blog post. Maybe that's a good idea for a blog post in August about how to use that.
Does anybody else have any other questions before we close? Well, if not, you always have the option of course, emailing any questions, and you can follow up either with myself or Carsten at any point after the webinar. And we hope to see you for our next one. Thank you all for attending, and we hope it was informative for you.
Thank you, Paul. Thanks, everyone. Have a good day.